right, welcome to chapter 8.2 in our calculus book, Areas in the Plane. This is a pretty straightforward and simple, I think, process, so it shouldn't take too long to go over. But imagine what we've been talking about before. We want to know the area between A and B, and we have said under the curve y equals f of x. And what we meant by under the curve is we meant between the curve and the x-axis. So really what we were saying is that the height of this rectangle is f of x minus 0, because its base is at 0 and its top is at f of x. The width is delta x, and we get the sum of the f of c sub k dot delta x, assuming constant widths, and we turn that into the integral from a to b of f of x dx. Hopefully that concept is pretty easy and straightforward for you now. Well, let's look at a different situation where we want to know the area between two curves instead of just above the x-axis. Okay, well, let's do the same thing. Here's a rectangle. It has width delta x, and it has height f of x minus g of x. Now, notice that in this case right here, f of x is positive, g of x is negative, so that length, f of x minus g of x, will actually make both of them positive. What if I was up here, f of x minus g of x? Well, okay, f of x is a positive, but the length of the height of the rectangle is not all the way to the x-axis. Well, we subtract g of x, and boom, we're still good. And then let's look at a third scenario where they're both negative. Well, I take the f of x and I subtract the g of x, and I'm going to get some positive number. Now, does it matter which direction we go? Well, it turns out that if we put an absolute value around this, then it really makes no, wait, why did I say that? Disregard, disregard. No absolute value. I'm erasing the absolute value. I misread my notes. Actually, I just have a set of brackets around it. And all right. So how do we find the area from A to B? Well, we take the sum of the f of c sub k minus g of c sub k, times it by the width of the rectangles. We'll assume constant width. And now we have the integral from a to b of f of x minus g of x dx. So let's go back a little bit. Let's talk about this one right here, the one where I sort of went off the rails. F of x will in fact be negative. We're subtracting g of x. So what we're going to end up with is we're going to end up with this being negative g of x. And then when we add our f of x, we will take away, let's make that red. We will take away that bit right there. And so f of x minus g of x still works. All right, quick example, finding the area in the plane, and then we'll have a few more examples, but we'll put them into different videos to shorten everything up. We've got y equals secant squared of x and y equals sine of x. We want x between 0 and pi over 4. Taking a quick look at the graph, here's what we see is that secant looks like this, sine looks like this. Here's pi over 4. We want this area right here, so we take the integral from 0 to pi over 4 of secant squared minus sine dx. Mathematicians will shout at me for not saying secant squared x minus sine of x, but I do it anyway. And we know that the antiderivative of secant squared is tangent of x. We know that the antiderivative of minus sine is cosine of x. We're evaluating from 0 to pi over 4. We know that tangent of pi over 4 is 1. We know that cosine of pi over 2 is root 2 over 2. And again, I'm just looking at the unit circle here. Remember, unit circle, theta, and then cosine, comma sine. And pi over 4, of course, is one of our standard angles. And then minus the 0 values. Well, tangent of 0 is 0, and cosine of 0 is 1. And so what we get is that the area between these curves is, in fact, root 2 over 2 units squared. And that's an exact value which we want when possible. Obviously, root 2 over 2 is an irrational, so if you were to just shove this into your calculator, you wouldn't get quite as accurate an answer. So, why don't you guys in my class go ahead and do exercise 1? We'll be back with the next video and a few more examples. Thanks for watching. Hope you learned something.